Okay, just to backtrack a little bit, just to review, when light hits a surface, three things can happen. The light can be reflected, it can pass through, or it can be absorbed. Okay, the first thing we already talked about was reflection, that when light bounces off of a surface, it's reflected, and there's a law for reflection that the light actually bounces off at the same angle it came in. Picture you and a friend. Here's you, here's your friend, and you're bouncing a ball back and forth against a wall. You would throw the ball at the angle that you want it to bounce off of. Light does the same thing when it hits a surface. When the surface is smooth, you have what's called specular reflection, and that produces clear images like a mirror. But when a surface is not smooth, when it's bumpy, the reflected angles go everywhere, and you don't get a clear image, and this is called diffuse reflection. Okay? So where we left off was transmission of light, and this is when light goes through objects. Okay? When objects are transparent, they are see-through. Examples: glass, water, and air. Objects that are translucent, like wax paper, allow some light to go through. Okay, raise your hand if you know what I mean about wax paper. Or stained glass. Okay, where the light travels through, but you can't see through it clearly. Okay, that's called translucent. Opaque materials do not allow light to travel through. You can't see through opaque objects because light does not go through those objects. And these types of objects cause shadows. Okay, for example, your shadow. You cast a shadow because light doesn't travel through you. All right? Absorption of light. When light is absorbed into objects, it's converted into some other form of energy, such as thermal energy. Apples look red because they absorb all the color of light except red. So colors that you guys see, you're actually seeing the colors that are not being absorbed. You're seeing the colors that are being reflected. So things that are white reflect all the colors of the rainbow. Because remember that white light, like the light in the classroom or the light from the sun, is all the colors of the visible spectrum combined. So when you see white objects, you're actually seeing objects that are reflecting all the colors of the visible spectrum. Brenda. It's the same thing. The white part of your shirt is reflecting all of the colors of the spectrum. The black part of your shirt is absorbing all of the colors of the spectrum. So look, up here, black objects absorb all of the colors of the spectrum, which is why in the summer when it's hot outside, it is not a good idea to wear black clothing, because you're absorbing all of the light radiation, okay, which gets converted into thermal energy and makes you feel hot. Okay? And then the last concept that I skipped on accident when I was taking my notes, that was supposed to go over here with light going through objects, is refraction. Refraction is actually a pretty cool property of light. When light passes from one medium into another, it changes direction slightly because the water is more dense and it slows down the light. So look, we see the spoon up here, right? The water is thicker than the air. It slows the light down, and look where the spoon appears to be through the water versus being out here. Okay, when light speeds up, the refracted rays actually go out instead of in. This is because the light slowed down in the water. This is also why fish appear larger and closer than they really are, okay? Because the refracted rays are slowed down. Okay, and bring the images closer.